recording? Wait, can you? Oh wait, can you click on that?
It is.
It is. Okay.
All right.
All right.
I will play it.
You want to just switch seats then for
Yeah.
now? All right. Okay. Is this working, guys? All right, let me pin this or something. Does this work? Okay, I'll just hold it for now. Okay, so welcome guys to the second lecture of Intro to Backend Development. Today, we're gonna go over an introduction to frameworks. So for administrative stuff, the first assignment was due yesterday on CMS at midnight. The second assignment will be released by tomorrow. There's fall break next week, so it'll be due in 2 weeks, like 2 Sundays basically. And the next lecture will be October 15th. And in terms of like grading, hopefully we'll have it done by this week or something. But I mean, it was like pretty straightforward, so I don't think there should be any problems with that. Okay, so just getting started. So we're finally going to get into some technical stuff. So we're going to start with like, what is a server? And we can just say like, servers are just computers basically. So we can think of them as computers that are accessible from other computers. They're just like our computers that we use for personal use, or our Macs or Windows or anything like that. And basically a server just has a host. So on your computer, you have like local host, which points to your own computer, but servers have like hosts that are IP addresses. So for example, I guess you can, okay, never mind. Okay, so servers have IP addresses and they also have open ports. Wait, can we turn this off like, okay, cool. Okay, so so they have hosts and IP address. Hosts are IP addresses, and then they have open ports, and those go from 1024 to that last number. And there's also a bunch more that are usually used. For example, like 80 is HTTP, and we'll talk more about that later. So the most important thing that servers do are centralize information. So for example, like the servers that Google have receive search requests and return those results in a response. So if you went to google.com and you searched like, what is backend, right? You'd get a response back. And so we can kind of generalize that by just saying like servers receive requests and return those results as a response. So how do we talk to servers, right? This is like the most intuitive question. So the thing is like everyone is basically interacting with servers on a daily basis. The way the internet is architected is in like a client server model. So every time you go to a website, you're sending like a GET request, right, to the server that's under like google.com or something. So, so it's the server client model. And so, for example, if I went to http/www.google.com, we have the request, and it's sent over this thing called HTTP, which stands for Hypertext Transfer Protocol, and that basically reaches port 80 on the server. So here are some other basically like port mappings. So HTTPS is typically on port, or is always on port 443. SSH, which is something that we use to connect like, so for example, when your virtual machine is running, or you have a VM or a Docker container running, you can like SSH into it, which sort of is an abstraction of how this actually would end up working if you were connecting to a remote server. And then there's FTP, which stands for File Transfer Protocol, and that's usually done on port 20 or 21. And there's, I guess, like a common FTP client is like FileZilla. I don't know if you guys have ever heard of that before. But that's just an easy way to transfer files between the client and a server. So we have the other part of this URL, so www.google.com, and this is just a domain name. Okay, I think there was supposed to be more, but I can just like describe that. So good. One way to think about this is like, let me get some chunk. So we have us, so like maybe you're on your Mac and you go to google.com And basically, this will first hit one thing, and this is like, this will hit your router, blah, 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 some other stuff. And it's going to be like, Google, like, you know, where does this actually map to, right? Like, there's some IP address that this needs to map to. And then, so let's say, like, the IP address is, like, some random thing that looks like, that probably has, like, this format or something. So maybe this is, like, the IP address that maps to the server, and then the request will get sent to this server that lives under, like, this is the name of that server, basically. And then it'll hit the server, and then you'll get the response back. And then the other part of it, so which is the HTTP, will tell basically, like, when it hits the server, you should send it to port 80. So this will go to port 80. And if you send a request over HTTPS, then it would go to 443, and etc. Does anyone have any questions about this? Yeah, what's up?
Why would you use HTTP versus HTTPS?
Yeah, sure. So HTTPS is inherently a lot more secure. So like, for example, if I went to Chrome and then I went to, when you go to like a site that has HTTPS, it has like that green lock on it next to the URL, and that's because stuff that you send to the server is secure. So for example, if you are at like Starbucks and you're on an HTTP network or like a website that uses HTTP, and you send like a username or password or sensitive information, someone else on that network could actually see the traffic that you're sending. It's inherently insecure. So which is why there was like a huge push, I think like whenever HTTPS came out, to move everything to this new standardized format. So you can also think about it as like routers, like they have like WEP, I think that was the first one, but now they have like WPA, now WPA2, and each one gets more and more secure and encrypts your traffic using like a new algorithm, basically. So that's sort of the difference. Yeah.
It sounded like it was just a different port on the same server. So
Yeah.
why is it?
So like, if you think about it, HTTP could be accepted on any port, and it's just sort of like a standard across everyone that they've chosen this specific port to be available for HTTP. And it's the same thing with HTTPS, but it's 443. And it's just like a standard that's been like set in place, basically, that servers should kind of conform to that, or else clients won't know where to send their traffic. Yep. Does anyone have any other questions? Yeah, what's up?
What does the DNS server work always?
Where is the DNS server involved in this? Sure. So DNS is like this thing that handles something like this, where you have like google.com and it maps it to the IP. So for example, what's a good example of this? So for example, if I own the domain name like, oh, okay, here's a good example. So Google owns google.com, and there's some DNS providers that basically say, oh, I want google.com to reroute to some IP address, and then Google, because they own this domain, owns everything before it. So they own like mail.google.com, right? Or maps.google.com. And DNS is something that basically handles this sort of like rules. So you add these rules to the DNS provider, and you tell them like, hey, I want this to go to this IP, this to go to that IP, this to go to this IP. So I don't think we'll cover DNS in like detail for the purposes of this class, but yeah, if you're interested in it, you can always just post and we can answer, post on Piazza and we can answer more questions. So, okay, so next up we have what is a request. So the request is basically what's getting sent to the server, and we can think about it as like a method plus data. So the methods that we have are get, post, delete. So those are kind of like HTTP verbs. That's what that's called. And then data, it's kind of confusing, like what is the actual data that's being sent in a request. And so we can think about methods as a standard. So HTTP, at the last word of that P stands for protocol. So it's just an established set of rules for communication. And there are other protocols that we won't really go through. For example, FTP for file transfer protocol. But for the purposes of this class, we'll be talking about HTTP. And HTTPS follows the same protocols. It's just like handled in a different way, basically. So methods indicate purpose. So we can say like usually get is for information retrieval. Every time you search something in your browser, that's sent as a get request. Post is usually for information transmission, and those are the two most commonly used verbs, HTTP verbs. Some of the others are delete, which is self-explanatory for deleting information. There's also put and patch, but the last two are pretty rarely used. So, in addition to the data that we think normally gets sent, there's also a lot of metadata, so data about the request. So if you've ever gone to like right-clicked in Chrome and gone to the inspect thing and look at these requests that are being sent to the server, there seems to be a ton of like extraneous information that doesn't really make sense. For example, like the source, the destination, where you're sending it to, the type of request, and there's a lot of like device information that might get encoded, and that sort of allows the server to understand like, oh, if there's an error, like what kind of device did it come from, right? So this is sort of included in every single request that usually gets made. And there's also ways to like mess with the headers. So for example, like if you take this class and you know like, oh, my device has these like pre-encoded things, like can I change these values and stuff like that. So let's see. And in addition to all of that, which generally automatically gets sent by the client, there's additional information. So for example, on Google, we might have a search query, sent messages, user credentials to log in, bank account information if you're logging into Chase or something, and that usually gets sent in the body of the request. Does anyone have any questions up to this? Yeah, sure. To this slide or the one? Okay, gotcha. Okay, so there's more standards. Data in general is non-uniform. For example, like if a server was taking in data, you know, how would the server know what kind of data to expect? How does the client understand like what kind of data to accept, right? So we have some agreed upon formats. So the two most famous ones, or the one that you guys have probably heard of, is JSON, which is JavaScript object notation. There's also extensible markup language, also known as XML, which generally is not used. So the process of serialization is sort of like taking a data format and converting it into this format. So JSON is pretty, I guess I can just like draw a picture on the board for it. So JSON is generally like sent in a dictionary form. So we have something like this. We have like the braces, and then we might have like generally maybe something like a status. So this is the status of the request that you sent, and maybe it's like 200, which generally stands for the request was sent successfully, and then maybe there's like a response. And maybe it's like success, like you were able to log in or something. So it's a key value pair dictionary. Has anyone here not seen JSON before or heard of JSON? Okay, great. So so we can look at a specific GET request or with a query. So basically, if we wanted to, so if you went to Google and you searched a query, it actually goes into the URL and looks something like this. And so the way it works is you pass data through the URL parameters, so not the body of the request. And so this is just getting appended on. So if we go back, the first question mark here is to say like, this is the end of the URL. Here are some get parameters. And again, these are just like standards that have been agreed upon. So we have the question mark followed by key value pairs, and those are separated by that ampersand. So it's key 1 is mapped to value 1, and then key 2 is mapped to value 2. And if you write a backend, you can basically parse for any key value pairs that are sent through. So if we went to the sign-in page for Google and we went to like that URL basically on the slide, it's pretty unclear, right? Like where are the username and password here? So this is an example of where we would send it in the body of the request. So I didn't make this slide, but there's the username and password that, okay, so yeah, so you can usually, or for post requests in general, you're always passing data in the body, and the specified data standard that's mentioned here is generally JSON. So it's just key value pairs. And the thing is with post requests, it's not obvious to other people, right? For example, like if you were, so there's ways that you can look at web traffic that's being sent, and you can see the URLs that people, like the requests that people are making to servers. And for example, if this was in the GET request, in the URL, people would be like, oh, here's the username and password. But post requests have some level of encryption to it under HTTP, and even stronger encryption under HTTPS. Yep, so this is kind of going back to that original point that from the question, but post requests don't have enough security on their own. Anyone can access the body without proper precautions, which currently is HTTPS. And it's almost like a guarantee that at some point in the future, someone will find some way to break HTTPS, and there'll be a new standard or a faster, more secure way of doing it. So what do servers say back, right? So how does the response work? So this is more standards, but usually you have a 3-digit status code that's sent back with any response that you get. For example, the 3 that we might be most familiar with are 200, which is for OK, 404, something like a file not found on the server. This is something we see a lot. And then of course there's 500, internal server error. This usually means there's some sort of issue going on with them. And just like the request body, there's a response body that's sent back in JSON serialization. Yeah, so that covers up to the response. Does anyone have any questions? Yeah, what's up?
So you said that HTTPS does or does not protect post parameters?
It does.
Okay.
It protects like all requests, yes. Anything else? No. All right, nice. Okay. So who are we even talking to? Server. And basically we can think of inside of the server, there's some sort of program that someone has written that's listening on an open port, which in the case of HTTP is port 80. So you can think about it as like in that model or the thing I drew before, the request hits the server and then it's like, oh, someone's trying to send a request to port 80. Let's see what program is running. Like what's going to handle that request basically. And that's the program that we're going to be talking about. So here's one that's written in C. So this is pretty early on when C was the most, I guess, like well-known or popular programming language. So this is a handler for requests written in C. However, we don't really want to be writing stuff like that every time we have to write a server for our own purposes. And the solution that we have here are frameworks. So this basically is a level of abstraction so that we don't have to deal with the semantics of networking. So we can kind of abstract away all of that handling that was on the previous page, just like the low-level stuff of how do we actually handle requests. And we can only write the logic that's most intuitive to us, right? Like, oh, like given this kind of request, we should have this output. So we can kind of just focus on the parts that are most important. And so the framework that we're going to be focusing on is Flask. So this is in Python. It's pretty easy to learn. It has really simple syntax. The developer has a lot of freedom. However, it scales pretty poorly by itself. So that's kind of like a con of Flask, but it has all the features of some of the more, I guess like, I don't know what the right word is, like more complex, I guess, more fleshed out frameworks, but those have a lot more complications that Flask lets us avoid. So here's some example Flask code. So we have a single object that encapsulates all the server configuration. So for example, back here, we have a lot of handling for all this specific like use case stuff. But here we just have one thing, like app equals Flask, and then underscore name, which we'll talk about later. And that just handles and sets up all these defaults for us basically. And app.run starts the server that runs the Flask app. So it's a lot shorter. It's pretty self-explanatory, I think. And that's, I guess, like that's part of the reasons why we've chosen to use Flask. Any questions? Yep.
Does Flask
I think a majority of the logic is written in Python, yeah, but I'm not too certain here. There are probably some, like, because Python in general doesn't really have great support for dealing with low-level stuff, so I wouldn't be surprised if there were some libraries that were written in C or something. Okay. So next up under Flask, so we have routes, and those handle requests. So routes are decorated functions, which we'll talk more about in the demo, and the requests for a specific path are handled by associated handlers. So it's easier if we see an example. So for example, the decorator is just like the @ sign, so it's app.route. So it says, hey, this is a route for this specific URL, so /search, and the methods that it supports is get. So if we wanted to have more methods, we could have get, post, or something like that. And then the function that gets called when some endpoint or some client wants to hit that URL, the method that gets called is search, which is defined right under it. And the return value of the function basically determines the response. So Flask does a lot of has a lot of nice things built in. So for example, if you send back a dictionary, it automatically converts it to JSON. You can also send files or redirect them to different URLs, which are both pretty common from a server perspective. For example, like if you sent a request to log in, then you might be redirected. So for example, if you're on Facebook, you log in, you get redirected to the home page after. So that's all sent through the response, basically. And yeah, so this is pretty close to the end of the slides. So what else is there? So other than Flask, we have a lot of other frameworks. We're not going to go into them in this class, but yeah, so Megan will go over a Flask demo with you guys.
All right, so if you go onto the Piazza, I posted a note about, so basically we want to clone this Git repo, so you can follow along. And also, if you want to follow along and make sure like, your requests are working, you can also download Postman, which we'll go over how to use. So basically, I'm going to start my Docker VM. What is going on? All right, let's try this again.
All right, if you guys have any questions, you can raise your hand, and I'll like help you guys out. If it's like something specific with this or something.
All right, yeah. So I'll clone it.
Scales poorly on its own. What do you mean by that?
Yeah. So one of the things that Flask is pretty bad at handling is like, if, for example, like Google has a ton of people hitting its servers every single day. Like one of the things that Flask isn't great at is handling a lot of requests. So it's not written to actually like be used in a production environment. So if that makes any sense, it's like mostly for the purposes of like development and like showing concepts and stuff. Yeah. Can you increase the text size?
All right. Let's make it. Is that better? All right. So I just cloned the demo repo into my VM. So I'm going to cd into it. And then if you go on the GitHub page, there's some instructions to how we set up our environment. So the first thing we want to do is install something called virtualenv. So when developing, you always have to worry about... Wait, what?
Never mind.
You always have to worry about different dependencies and like if I send my code to Young, will he be able to run it? And usually like, there will get some errors because he might not have the same thing installed as I do on my system. So how we solve that is there's a package called virtualenv, which makes basically like a virtual environment, and it standardizes like the dependencies that you have. So like if I send this to Young, he can set up it so he's running my code in the same environment that I'm running it in. So basically,
were people able to follow along?
Yeah.
To
have anyone
point?
have any
like,
problems so far, cloning it or anything? Yeah.
Do we have to run that command then before sudo?
Can you say that again?
Do we have to run the event/big/activate first?
Oh no. This is in order. I'll go through that step. Yeah, don't worry about that yet. So then once we have that, we want to cd into the demo/source directory. And how we can create like a new virtual environment is we can specify virtual env and then the folder that we want to create it under, and usually it's pretty standard to just call it this. So now it's basically creating all of the dependencies and our executables, everything that we need to run in this environment in this folder. So we'll let that install. All right, so now how we can start our virtual environment is if we do dot and then the folder name, bin, and then activate. And then we can see now on the very left that we're in our virtual environment. So now if you open this folder in like VS Code, so I have my folder here, wherever you cloned it. So I'll just open VS Code.
Does anyone have any questions up to, yeah, what's up?
So we're creating a virtual environment, a Python environment within Docker.
Yes.
What's the particular reason for doing that?
Sure. So Docker standardizes like the OS that we're running stuff on, but then, for example, let's say like my Python project, or like in this case we're using Flask. So let's say if we write some, I was using the wrong size, pretty silly. Okay. In the Python file, like let's say we have like import Flask. Flask, like anything else, is like has versions associated with it, so it's not really clear to Python what version to use. And for example, me and Megan both have this file. Even if we're both on Docker running it on the same OS, there might be a different, like she might be on a newer version basically. So we have a virtual environment specifically for Python, and inside of there, we're able to standardize like, oh, we're using Flask, like version, I don't know, like 3 or something, right? So it's similar to like a Python version. So it standardizes the packages that Python is using basically.
Because it pulls the versions from that list, like specifically those versions, so everyone has.
Yeah,
Oh yeah,
we'll
yeah.
go over it.
Yeah, you wanna?
Yeah, so if you look, the one file that we should have is this requirements.txt, which basically specifies like what packages are required to run this and like what version that we have that's required. So like Flask, we're using 1.0.2. So basically now if you go back to your command line, we need to install these packages. So there's something called pip, which is like a package manager. And we can do install, and then if we add this -r flag because we're saying like, hey, we want to install everything in this like file, and then we can specify requirements.txt, and that will basically install everything that we had in that text file with the correct version. So like if I send this to Young, then he could do the same thing to make sure he has all of the same packages with the correct versions installed. All right. So does anyone have any questions?
So one of the other things is like, why don't you just install those packages globally? It's because usually like if you have multiple Python projects, then even those might be on different versions of the same package. So each one should have its like own environment basically that you want to run the code in, which is why we have a virtual environment specifically for this project. So for example, like if we had a bunch of Python projects that we wanted to demo and they had different requirements, like we would be able to have those sort of like isolated, if that makes sense.
All right, so now next in our source file, we want to make a file for application. So we'll make a file called app.py because we're going to write it in Python. So first thing we want to do is like import the dependencies we need. So we're going to import Json, which will go into like when we're using it later. And then we're also going to want to import Flask. So from the Flask package, we want to import the Flask class and request, which we'll also go into later about using.
Do you want to make the font even bigger?
Yeah.
Also, like all this code will be available.
The completed version will be
Yeah, the completed
pushed
version will
to
be
the same
available
repo.
as well. So
All right, is that big enough? Yeah, so as Young said before, when we create our Flask app, we can instantiate it like this. So what name refers to, this like double underscore name, double underscore, refers to like our module or package's name. I don't know if there's a better way to explain that.
So in like Python, there are special variables that are surrounded by double underscore so they don't get like confused with other stuff. And name is just basically one of those. And that refers to the package or like the directory the app is under, if that makes sense. Yeah.
Yeah, so the app that we want to create is we want to create a backend for like basically like a to-do list. So we can just start with making like a dictionary with some sample task that that the user can interact with. And we want to map this right now to the ID to like the task. We'll go over more into why, but like a sample task would have, this ID would be 0. It has a description of say like, I want to do my laundry, and it has a done field that specifies whether the task is done or not. And then we can add, a couple more. So have another one. So yeah, anyone have any questions?
So this is in the same like JSON format. So this is just an example of like what a task or like what it might look like the return format and stuff. Yes.
Okay. So earlier, Young also mentioned how we can tell Flask to look out for certain routes. So like say we wanted to handle like the case where someone made a request to just like this dash, right? Or we can do task also. So basically we're saying that, hey, these two URLs are going to be handled by the same function. So if anyone goes to, just the / or task, this function will be called. So we want to start off by returning all tasks. So like say like the user wants to get all the tasks that are currently created, they can go to this route and then this function get task will be called. So now it's like, how do we return that to the client where they can view it in like a standardized format? So basically we can create like a response dictionary, and like for all our requests, I guess we want to make a field that's called success, like whether the request was successful or not. So in this case, it's true. And then our data, we want to return this list of tasks. So like, this one and this one. So we can do something kind of nifty. We can do list, and then we can do task.values, which basically takes all the values of this dictionary and puts them into a list. And then, so like this is a dictionary, but usually, as like Young talked about earlier, most HTTP requests are in the form of a JSON. So we can use our JSON package. So JSON has this function called dumps, which basically takes a Python dictionary and returns it to a JSON object. So we can just take our response dictionary and convert it to JSON. And then there's also another return value that we can specify, and that's like the status code. So like 200 404. In this case, because it's successful, we want to return like a 200 response. So basically, that's how we can specify our first route.
You want to demo this one?
Yeah, can you go to the bottom for?
Oh yeah, sure.
We have to do the run. So how we can get this to run is, so like, this is pretty standard. I don't know how to explain it, but let me just type it and then I can explain it. Okay, so basically when we run this, this like if statement of like if name is equal to main. That's just basically saying like, is this the main file that we're running it on? Like in Java, like you have like a main method. So it's kind of similar. Explain it. So like basically if we're like running this file directly, we have this app.run, which basically starts the server, and we can specify the host. So in this case, it's like, this is basically equivalent to like localhost, if anyone's familiar with that. And the port we want to do it on is 5000. So now if I go back to my terminal in my virtual environment and I type in Python and then app.py, we can see that it's currently serving this app, right? And it's running on this URL, this host with the localhost, and port 5000. Yeah. So if we go to Safari or like a web browser and we paste in or go to localhost 5000, we can see that we get this response of all of the tasks. So like we basically see like our dictionary that we specified in the response with our success field and our list of tasks. And then if we also go to like -task, we also get the same response. Does anyone have any questions up until now? Yeah.
For people who are running this in a virtual machine, how did you get the app.py file into the virtual machine folder?
Oh, your virtual machine is so tricky.
You can do shared directories, right?
Yeah.
Inside the virtual machine.
Yeah, we created the app.py file from scratch. Yeah.
Yeah, we like made it in the virtual environment.
But
You can do shared folders with VirtualBox if you're using VirtualBox and like apps through Windows stuff. I'm using it.
Any other questions?
yeah, so for Windows, so the Windows thing we will like there is a way to share directories similar to how we're doing it. And then we can post a guide on that after class or something. Yeah, so does anyone have any other questions? Or?
Yeah, so we look at the terminal, we can see that a GET request was made to this just /URL or the task URL, and we get like 200 response like we specified in our return values. So now if we go back, and now say like we want to like give the user a way to create a new task. So we can specify the route again and say we want to use the same task URL, but this time we want them to send a post request when they do it. We can say methods, and we can make it equal to like a post option. And we can call this create task. So basically, when Young was talking about post requests earlier, a user will usually send the request data in a body. And how we can do that, so we can get the post body of what the user sent. And for each of these requests, we have this request object, which basically contains all the data that this request contains. So how we can get the body is we can do request.data. So this basically gives us the post body that they sent in JSON form, but we want to convert this to a dictionary. So JSON has another library function called loads, which is basically like the opposite of what we used earlier with JSON.dumps. So this basically takes JSON and then converts it to a Python dictionary. So if we look at our post, when someone wants to create a post, they basically just need to send in the description of the post, basically what they want to do, because like the ID is like we handle that on our side, and when you first create like a task, like it's like when you type in like a task in like a to-do list, like it's by default not done yet. So we can get the description of what they sent by just doing post body because it's a dictionary, and then look up the key description. And then we can create a new task. So one thing we have to keep track of is like, what will the ID of this post be? So if we go back to our tasks, we can keep a task ID counter of what the ID of the next task created would be. So in this case, it would be 2. And basically we can use that to increment it to every time we create a new post to keep track of like what the next ID would be. Because it's a global variable, we have to specify in this method that we're using, this counter. So we can specify that the ID of this is task ID counter. The description is what the user sent in the body. And done is false. So now we want to add this to our list of tasks. So we can do task and then task ID counter, since it's the ID mapped to the specific task, is equal to this new task object. And then we want to increment the task ID counter in case we want to make like another one later. And then for our response, we want to return, so we're going to do like this json.dumps again because we want to return a dictionary, but then that's going to be converted to a JSON. So our success is going to be true. And then our data is just going to be this new task that we created. And then there's a response code called 201, which basically just indicates like, oh, like an entity was successfully created. Does anyone have any questions up until now?
What was successfully created?
So like in this case, it'd be a task, but like 201 is just like a universal status response for like created in general, which usually indicates like something new was like created. Yeah.
Where did the variable request.data come from?
Yeah, so Flask, so whenever we do like this, app.route decorator, it knows that like, hey, like a request is going to be sent to this URL, and that's kind of handled by Flask to give to us basically.
So it's just referred to as request, like that's just.
Yeah, you can assume that like, because like we imported request earlier, but like all Flask requests, all of these like methods like come with a request. Let me put this to the end of the file. Did anyone have any other questions? Yeah.
So I understand what the at route thing does like logically, or
Yeah.
what it does to the program, but on a kind of Python programming language level, what exactly does that at sign and then app.route mean?
So it's called like a decorator, and I guess like the simplest way to put it is like it's like a function that takes a function as an input. If you have like more questions on it, yeah, you can always feel free to post on Piazza, but it's not something we're gonna cover in the class. Yeah.
So to test this route, we usually can't use like a web browser because usually web browsers make only GET requests. So there's this thing called Postman, which allows you to make all different types of requests, GET, POST, delete, and lets you like send bodies. So if I open Postman and, okay. So basically I can say like, I want to send a request to localhost 5000 task, and I want to make this a post request. So I need to make sure it's running. Yeah.
Oh wait, go down. You deleted the close parentheses at the end of this line.
Okay. So if we go back to Postman, I can indicate the URL I want to make a request to. Is this big enough? No. How do I make this bigger? All right. Yeah. So I can indicate like I want to make a request to localhost 5000 task because that's the route of this create task method, and I want to send a post request, and I can specify a body, and I want to send a JSON. And like we said earlier, when you create a new task, the user needs to send like a description. So we can say our key is description and say it's like study for prelim. So now if we, let's see. So now if we send this post request, we can see that it was successful. It has, and then here's our new task that was created with the ID of 2, our description, and it would say like done is false. Yeah, and then we can see like the status right here is 201 created, and this is basically like kind of what 201 like symbolizes. So now so we created our new task. So now if we do a GET request on all tasks, we should see that our new task has been added to this list of tasks. Does anyone have any other questions? All right. What's next? Get task. Okay. So now we want to make basically a route. So say a user knows an ID of a task, but they want to get the information of it. We can specify a route called task. And then we can also specify what URL parameters that they will send. So we can specify we want an int that corresponds to the task ID. So this is basically saying if I have a URL localhost 5000 task, and then I can basically put any int. So say I wanted to get task with ID 10, I would do something like that. So this what this does is basically parses our URL and extracts this int and puts it into a variable called task ID. So that's basically what it does, and you'll see it later when we test it. So we can call this get task, and this function takes in a task ID because it's what we got, what we specified in the URL. So one thing we want to check is to make sure that the task ID is in our current list of tasks. So we can do if task ID is in task. We can find that task by just doing a dictionary lookup. And then we can return that task by saying success, true, data, task with the 200 response code. So in the case that we can't find the task that they requested, we can return a different response by saying, was it successful? No. And then we can specify an error message. So in this case, it would be task not found. And then earlier we went over briefly over a response code 404 not found, which I'm sure that you have encountered before. So yeah, so now if we, let's see. Okay. So now we go back to Postman and say we want to get all tasks. And so we have these two tasks with ID 0 and ID 1. If we want to get the task with ID 0, we can just add that to our URL and send it, and we can see oh, we just get the task that we were looking for, or 1. But say we indicate we want ID 10, even though there's no task there. We'll see that we'll get this error message and this status 404 not found response. Does anyone have any questions?
Oh yeah, so the reason, so he said number 2.
Oh, yeah.
Yeah, if you want to go to the terminal.
Yeah.
And show.
Yeah, so every time we make changes to this app.py file and we save it, the server will restart because it notices different changes, and every time we restart, this task dictionary is reinitialized.
Yes, so there's no persistent storage, but that's something we'll be dealing with in future lectures. But yeah, it might seem weird that the server restarts every time you change the code, but it's actually really convenient if you think about it, because you don't have to keep going back and then restarting stuff over and over again. And it's actually something that's pretty common in most web frameworks now.
All right. So we'll go to the next one, which is update task. Okay. All right. Oh, yeah, I got these pretty quick. Okay. So the next one is say we want to update a task. So we want this to have basically the same URL as getting a specific task. But we want to make this a post request. So basically, if a user wanted to update a task, they would specify the ID of the task they wanted to update, and then send a post body with the new information. So you can make a function called update task. So getting a single task, we want to see if this task actually exists. If it does, we want to find that task. And then like when we were creating a new task, we want to abstract like the body that they sent. So we can do the json.loads with the request.data. And then, so when a user wants to update a task, they can update the done field and this description. So we can say, so we have our current task, and we want to change this description to be the description that the user sent. So we can do post body description. And then we also want to update the done status to be what the user sent. So and then we want to return to the user this new updated task. And then similar to like if we don't find the task, we can basically just return the same response. Does anyone have any questions? Yeah.
So can you show like sending a post request with this code in Postman? Could you demonstrate?
Yeah, I was gonna get to that. Yeah, so if we go to Postman, and so if we get all tasks, and say we want to update task with ID 1, we can do post request, specify the ID 1, and then in our request body, say we wanted to update the description to like study for prelim, and we can specify like say like the task is actually done, so we can update it to done like this. So basically this is like the body that's going to be sent to the Flask server. So if we send this, we can see that it was successful, and then now our original task with ID 1 now has this new description and this new done status. So when we get all task, we will see that, yep, it's been updated to reflect a new description and the new done that the user sent. Any questions? All right. And then our last method is for, say we want to delete a task. So we can specify basically the same kind of route. And this time, our method that we want to use is a delete. So we can say delete task. And again, we want to check if this task even exists. If it does, we want to find this task. And then we want to delete it from our task dictionary. So Python, how you delete it is you just do this del keyword, and we say task ID. And generally, when we delete something, we want to return it to the user. So we can return the response with the deleted task. And then if we can't find it, then we can basically return the same thing as we did for the previous ones. And then, so now how we can test this, let me make sure so if we get all tasks, we can see that we have, 2 tasks, are the ones that we initialized at the very beginning, but we want to delete, say, like the one with ID 0. So we can say the URL has, 0 is the ID that we want to delete, and we can specify that we want to do a delete request. So now if we send that, we can see that it was true, it was successful, and that this is the task that we just deleted. So now if we get all tasks, we'll see we only have 1 task left. Does anyone have any questions? All right, I think that's finished right on time.
Yep.
I'll push to the same GitHub repo with the completed code for if you guys want to look at it. This is very similar to the next assignment, so I would highly recommend making sure that you understand what all this does. And yeah, that's it. If anyone else has any other questions, you guys can come up here. right on time.
Stop the recording.
Yeah.